Question number 5. This question is from Newton's laws of motion. Two particles of masses zero point 0.8 kg and zero point 0.2 kg are connected by a light inextensible string that passes over a fixed smooth pulley. These are two particles. This is a lightweight string passing over a pulley. Pulley is smooth, no friction in it. The system is released from rest with both particles 0.5 meter above the horizontal floor. This is horizontal floor and these two particles are 0.5 meter above the floor. In the subsequent motion, the 0.2 kg particle does not reach the pulley. During the subsequent motion, 0.2 kg mass does not reach the pulley. Part A of this question is show that the magnitude of the acceleration of the particles is 6 meter per second square. We have to show that the magnitude of the acceleration is 6 meter per second square and find the tension in the string. First of all, we will represent all the possible forces acting on this system. The weight and there is a force that is called tension due to these particles. There is a tension. Tension is a force. Direction of the tension will be towards pulley. Tension towards pulley. Tension towards pulley. Tension will be same in the string. Now weight acting vertically downward 0.2 g. G is the acceleration due to gravity since W is equal to mg. Weight of zero point 0.8 kg mass is 0.8 g. Now for both particles we will make two equations. For particle 0.8 kg, equation of motion will be since this particle 0.88 kg is heavier than 0.2 kg. As soon as the system is released from rest, as soon as we release the particle 0.8 kg starts to move downward and particle 0.2 kg starts to move upward. Acceleration will be same in both particles. So equation of motion for particle 0.8 kg will be we are using here Newton's second law of motion. F is equal to ma. For zero point 0.8 kg mass, the equation of motion will be according to the Newton's second law of motion 0.8 g minus tension is equal to ma, and for particle 0.2 kg equation of motion by using that Newton's second law of motion will be T minus 0.2 g is equal to ma, because this particle moves upward, so net force will be T minus 0.2 g is equal to ma. These are two equations. We will solve these two equations simultaneously to find the value of acceleration and tension. Now simplifying, we are adding these two equations, minus t and plus t cancel out. Point 8g minus 0.2g becomes 0.6g is equal to zero point 0.8 plus 0.2a, 0.8a plus 0.2a becomes 1a, and from here a is equal to uh, 0.6 into g is 10, a is equal to 6 meter per second square. This is acceleration. Now we are putting this value of a in any equation. We are putting this value of a in the first equation. Let this is equation 1, this is equation 2. From equation number 1, 0.8 g minus t is equal to ma. M is 0.8 and a is 6. From here t will be 8. After calculation we get 8 minus 4.8, that is 3.2 Newton. This is the answer. This is the tension in the spring, and acceleration is 6 meter per second square. These are the answers. Now part B of this question is, when the 0.8 kg particle reaches the floor, it comes to rest. Find the greatest height of 0.2 kg particle above the floor. So we will again make the diagram. This is pulley, string passing over the pulley. The distance of the particles from the floor is 0.5 meter. Weight of this particle 0.8 g. Weight of this particle is 0.2 g. Now, when the 0.8 kg particle reaches the floor, it comes to rest. As soon as the particle is released, this particle 0.8 kg starts to move downward and will reach the floor with a speed. First of all, we will find the speed with which the zero point 0.8 kg mass reaches the floor. So for this, we have this data starts from rest because they are released. When they are released, the initial speed will be 0 for both particles. For 8 kg mass, For 0.8 kg particle, initial speed is 0. Final speed we have to find with which this particle 0.8 kg reaches the floor. Acceleration we have to find. Acceleration we have already found that is 6 meter per second square, 6 meter per second square, and distance is from the particle to the floor is 0.5 meter. We are using this equation v square minus u square is equal to 2 as. V square u square is 0, 2 into a is 6, distance is 0.5. So after calculation we get v square is equal to 6 and we get v is equal to plus minus 6 under root y, but we are taking its magnitude, that is 6 under root. This is the speed of the particle 0.8 kg mass, and this is the speed, final speed with which the particle 0.8 kg reaches the floor, 6 under root meter per second. Uh, the particle 0.8 kg reaches the floor covering a distance of 0.5 meter, and the particle 0.2 kg mass uh, moves upward and covering a distance of 0.5 meter. It reaches at this position, at this position. This distance is same as this distance. Particle zero point 0.8 kg mass cover this 0.5 meter, and zero point 0.2 kg mass cover this distance, that is also same 0.5 meter. So this is 0.5 meter. The particle 0.8 kg reaches the floor and comes to rest. But this particle comes here and it will continue its motion and reaches at this point, and due to gravity it becomes to rest at this point. At this point, particle 0.2 kg comes to rest at this point due to gravity. Now we will consider this motion of this particle 0.2 kg to find this distance. To find this distance, this height, we have data. Final speed of this particle will be 0. Initial speed is same with which this particle 0.8 kg reaches the floor. So that is 6 under root. So we are taking 6 under root speed of this particle 0.2 kg. We are taking 6 under root. So because the speed of the particle of 0.8 kg with which it comes to floor is same as this particle 0.2 kg. So initial speed we are taking 6 under root, final speed is 0. Acceleration due to gravity due to upward motion is minus 10 meter per second square. Now from here we will find uh, this distance. So we are using this equation for 0.2 kg particle, v square minus u square is equal to gs. V square is 0. Initial speed U square mean under root 6 square, that becomes 6. 2 and G is minus 10, and S we have to find, that is the height. So from here we get S is equal to 0.3 meter. So this distance is 0.3 meter. This distance is 0.3 meter, but we have to find the greatest height of 0.2 kg particle above the floor. So it is very clear that is the greatest height is particle 0.2 kg as this greatest height. So we will add these heights: 0.5 plus 0.5 plus 0.3. So this is the greatest height of particle 0.2 kg from the floor. So greatest height above the floor of 0.2 kg particle will be 0.5 plus 0.5 plus 0.3. Finally, we get the next greatest height, that will be adding these. We get 1.3 meter. This is the answer.